Hi guys, welcome along to Design Technology TV. Today we're continuing our series for the OCR NEA, and today we are looking at quality of planning for making of the prototype and your risk assessments. So for the planning of your prototype, the important aspect here is that you are looking at this in a different way from the way that you looked at your technical specification. Your technical specification was looking at making your product in a factory with real life machines and real world production systems. What you're looking at here instead is how you're going to manufacture and make your product as a prototype in the workshop space that you have access to. So it means there's differences in the ways you're approaching it, and there are also differences in how you're going to do it. And it might mean that the production of this is very different from the one that you've already looked at for a professional piece of manufacturing. Clearly, you're not going to be able to injection mold component parts, etc., etc. So with that in mind, you should be obviously looking at modeling in a different method to create something that represents and is close to the plan design as you're able to do so. What you're doing is you're looking at all requirements of the product. The most important aspect here is that you are presenting your ideas of how you're going to manufacture your product to a third party in plenty of detail, to the point where they should be able to understand how to manufacture and make your product without without you being there. So you should be able to pass them on your planning and say, here's all my information, off you pop, and then they should be able to then manufacture it for you. Obviously, that's not going to happen because you're manufacturing yourself. But with that in mind, it's something that you need to be planning for in terms of the level of communication if you're going to get the higher grades. In terms of what you're doing, you should show a plan of the making, include all steps as much as possible. In addition, you should be looking then at how you're going to do it. It's a workshop focus, as I've mentioned. So with that in mind, you should be using the workshop machinery that you have access to in your workshop, and outline how you're going to use those machines as you go. The likelihood is you're going to have to use jigs, templates, and you should also be considering tolerances throughout. What is suitable in terms of the manufacturing of your product, and that will then feed into quality assurance and quality um, control measures that you're going to put in place. You should also be looking at linking in risk assessment very closely to what you're doing. And what you'll find as I work way through this is that I touch on bits where either it's missing or it could have been done better. And from the information you've got here, you'll have opportunities to select how you wish to approach your planning. There isn't one defined, this is what you do. There are some better options, and we'll talk about this here. The other thing you're going to do is you're going to manage your process. So that's going to be managing your time, i.e. how long a given task may take to perform. It might be that a 3D print has a certain time it needs to be on the machine for, or it might be that you've given allocated a certain amount of time to sand and to shape certain component parts using certain methodologies. You should also be thinking about the amount of materials you're going to use and the processes that are involved. As always, we'll look at Mark Band 4, so comprehensive and relevant. So you're focused on what you're doing. You're not just talking about any old planning. It is focused specifically on the prototype that you are manufacturing. You should be putting considerations of health and safety and aspects like that, with consideration of your technical specification. As we talked about, though, this isn't the tech spec, so it might be that there are very different approaches to the ones that you've identified as in your technical specification compared to how you're going to do it here. And also you need to show that you are managing the process, i.e. you might come up with a plan and that might not work. So you might have to try other ways to manufacture the product in your workshop because you might find that local issues prevent you from doing things or make your life a little bit more difficult, or something you thought would work didn't. The likely content is going to be you looking at some kind of flowchart or table that allows you to show which steps you're going to take and how you're going to approach the final prototype that you're making. Importantly, at this stage, is also you'll note that within this text, there's bits which say prototypes. You may choose to make more than one single prototype to evidence your product. So an example of this is a architectural outcome. It might be that you make the whole building, but of course you need to have evidence of the system that you plan on using for your product. And with that in mind, you might then have components where you show how a prefabricated wall joins to another section. So it's a separate model, entirely different to the full model. And indeed, you might have another model which is deliberately designed to allow you to test an aspect of it, whether that might be a waterproof seal or it might be a component or a linkage. You might also do that. So it's true for any product you do. Whilst you may have a single product that allows you to do everything, you may also find that having more than one prototype allows you to test further down the line. So have a consideration of what it is that you might need to do. You're then going to plan what machinery, equipment, materials, and tools you're going to use as you go through. You'll also look at bought-in component parts as well. There's nothing wrong with stating that you'll use bought-in component parts for whatever it is that you're doing. Um, be mindful though, if you bring in too many component parts and aren't manufacturing very much stuff yourself, then that's probably going to affect your mark negatively. What you do want to be doing is making sure that you're using appropriate bits. So using screws, bolts, that sort of stuff is absolutely fine. But um, disassembling an existing product and using large proportions of it is not going to be great in terms of showing your skills at making, and you won't be awarded marks for those component parts that you use. As we talked about, quality assurance and quality control should be part of this, looking at jigs and templates and then making sure that people know how they're using them, what they're checking for. And you'll see some examples of how that's not done particularly well as we work through some of the slides in this. There should be close reference to risk assessment, and we'll talk about that as a separate section, but you'll see how that's linked in too. And then as we talked about, you're going to have estimates of timing, sequencing, what order of events you're going to do. Importantly, this is a working document, so that means that you will plan ahead, then you do it, and if things need to change, you would show how they've changed and why you've changed them. It doesn't mean that the stuff that you did earlier was worth no marks, because you're actually trialing things, and if it hasn't panned out the way you thought, you'll probably get more marks for the fact that you've then changed your methodology or identified there's weaknesses in your manufacturing process that allows you then to make a better quality product. Common mistakes are the students simply don't break it into enough parts. There is then also they think that orthographic drawings they've done for 1.6 are marked in this section. They are not. They're a different section. That is the technical specification for the real life, real world product. In here, though, there are marks available if there are significant changes to the product. So you might have decided that a certain component part would be manufactured a certain way in real life, but to manufacture it for your prototype, it needs changes. And that might mean that there are new orthographic drawings entered here, and they can be awarded marks in this section if they are specifically about the product you are about to manufacture. And also, students have a lack of communication in terms of the components they've got. They might understand the process, but it can become very jumbled for someone looking from the outside. So numbering or lettering your component parts, showing images of the product as an assembly so we know which part you're actually manufacturing at a certain time really benefits us to understand what's going on. As always, higher lower marks. Higher marks are you making sure that you've got a system in place, that you're showing how you've made decisions and that it's suitable for someone as a third party to look at. This is the first example. Now, when you look at these are snapshots and only little bits of the slides. So often you'll find that these student planning will do sort of 10, maybe 10 slides of all the different component parts, depending on how detailed they've gone. Within that, there's different aspects, one of which is a cutting list. So a cutting list is appropriate, but it needs to be in a fair amount of detail. This is okay, and it talks about some component parts of the product, and it covers most of them. But the likelihood is that there would be more component parts, and it could be more closely linked here to what the parts are, i.e. there could be images to allow us to understand what the backrest looks like, what the seat base looks like, what the desk is, etc., etc. They could also be numbered or labelled. They might well have been in images or slides before this. Importantly, what we've got here is we've got a length, a width, and a depth. So the candidate here is looking at each of those things and evidencing their understanding of it. Indeed, when you come to order the stuff or require that from the workshop, the likelihood is that your technician or demonstrator is going to look at this and say, right, this is fine, but I need to know specifically what it is that you want so that I can order it in for you or to check that they've got stock. So being precise here is really useful and allows you to then get the things that you need. This candidate then moves on into some production planning. This is not very good. It's quite unclear what's going on. Yes, we've got what the parts are. We can see those at the top. That's useful. But when we actually look at this, we've got the start and then we've got random columns, and I don't really understand which order the columns need to go in. Equally, we've got opportunities here where they say, right, make sure the MDF is the correct dimensions. Great. But then what dimensions are they? So there's no reference to the dimensions that possibly we had on the previous page. We've then got bits where we're talking about health and safety and risk assessment. So we've got the bandsaw use and circular saw. That's fine. But what are the risks? which parts are being cut and what cuts are being done. So it's a bit generic in terms of its effect or its focus. And then when we look at the red side, we've got a series of columns. I'll be honest, and I have no idea what order those tasks are supposed to be undertaken, and then they all meet at the same point as a finish. So it's pretty unclear where it's going. This could have been done with a bit of clarity in terms of a flowchart, and you'll see examples of that now. So flowcharts are probably the strongest way of doing it. They're also possibly the most time consuming, but they're probably worth more marks because of the fact that they have such detail and depth in them. So it's the way, if I was approaching this, it would be the way that I did it. Now we've got this flowchart and you can follow this round, it's fine. There are good bits and bad bits about this. There's good bits in terms of the fact that we're seeing that there are tolerances popping up. Great. But the tolerances seem to be quite large. I mean, there's a 4mm tolerance, and this is a fairly large frame section component part, fine. But 4mm is quite a range of tolerance, given the fact that you're trying to get bolts and other bits in place. So are there issues with that in itself, and is 2mm for everything correct? The next up we've got some questions which are checks. Are all the tubes the same length and they fit well together? Same length, fine, we can measure that. That's not a problem, although it doesn't say how we're measuring it. Equally then, does it fit well together? How do we know that? What fit are we looking for here? Is there an example where we can actually understand which bits need to fit where? Do they fit together? Do they fit inside each other? Do they fit into something else? That's very unclear. We also have bits where at the bottom we've got another one which says cut the sheets, fit across, do the sheets fit across section well? What does that even mean? So there are quality checks, but it's really unclear how they're undertaken and what purpose they are having, and also what do they mean by the sheets. So you need to be specific and make sure that they're done well. We then have this way, which is then planning in a table format. There's positives and negatives about this. Negatives are the fact that it's fairly generic and it's quite difficult to understand what specific parts are being manufactured and what's actually being done to those. There's other aspects though which are a little bit better. So we've got risk assessment on the end, so we can see how the risk assessment is being planned, and also quality control for the steps. Although again, it's a bit of a generic approach rather than being specific. But we also then have commercial and industrial. You probably, rather than commercial and industrial, will be looking at industrial and then workshop rather than commercial, because it makes more sense. How the product would actually be made in those two different settings and the differences between it. It shows a very good level of understanding when you can compare the two directly against each other. The other thing to bear in mind is this says technical specification, planning for the making. Right. Really? So there's some issues here in terms of, is this the plan manufactured by the student, or is it in industrial setting in the factory? So be careful with the way that you are naming your sheets. 5.3 then is risk assessment, and what we've already covered this to a degree, but you should be avoiding generic responses and be as specific as possible to the task that's being undertaken. They should be comprehensive. They're going to be linked closely to your planning, and I would expect to see them within your planning documents where you refer to specific tasks. We'll talk about that as we go through. They should be specific to the parts that you are actually manufacturing. So if you are cutting something on a bandsaw, if you give us a generic health and safety bit of information about a bandsaw, fine, that's okay, but it's not going to get you high marks. What you want to do is you want to have that kind of generic intro, but then you want to then cover specific tasks that you are undertaking for the component parts that you are specifically manufacturing. So be closely aligned to what you're doing. Also within that, you're looking at mitigating and managing risks. So what are the risks involved? Identifying what they are, but then how could you make them safer? How could you make the working practice safer for you? As you should know by now, that risk assessment is about analysis and evaluation of the possible situations that are arising. You need to be slightly moderate in terms of the way you're approaching it, so you shouldn't be looking at this and go, well, the outcome of everything is death, because it's not. What we need to do is we look at the low risk compared to high risk scenarios, and also likelihood within that. So how likely is something going to happen? It might be that something is very dangerous in terms of the severity of the injury, but it's incredibly unlikely to happen, which makes it probably possible that you may undertake such a task. So be careful of where you're going with this. I mean, you could argue that you could get a little cut in your finger, that could go septic, you could get sepsis and die. yeah, it could happen, but it's really unlikely. So think about the opportunities where you're talking about real life situations that are likely to occur. In terms of content, showing tools and processes and equipment and your understanding of how they're used, where they're used, why they're used the way they are. Show that you're putting systems in place, whether that's jigs or other aspects, to make your project work as carefully planned as possible and as safe as possible. Within it, talk about relevant safety hazards and issues that and how you're applying control systems of control to it to make sure that your life is or your health and safety is covered. In terms of what you're doing, if you're doing this, you may take photographs of yourself using products, and often students do, to demonstrate their safe working practice. Often these photographs are taken after um, the actual manufacturing has taken place, or they recreate photographs, because obviously during the actual processes you're thinking about doing the processes rather than photographs. First of all, I would encourage you to get photographs as you do it, because you're not setting up twice. Secondly, though, if you are doing the sort of the setting it up to pretend that you're doing it again, watch out for issues of health and safety. So if you're there using a machine and you haven't got goggles on, which you should have, or safety glasses, then that's actually going to go against you and you will be marked down and it will have a negative outcome. So watch out for how you portray the safety that you've undertaken. Common mistakes: just covering generic risk assessment and not looking at specific issues. So just giving us workshop health and safety, but not actually looking at the tasks that you're undertaking. Um, Showing no understanding of control measures that could be put in place to make your task safer. And also, there's an opportunity here to look at the product in use. So risk assessment has two sides of it. One is obviously you making your product in the workshop, but in terms of marks for the risk assessment, you can also pick up marks thinking about the wider issues that are associated with your product and your real life product work used in real situations. So if you've designed a product that's designed to lift someone up and down as a lift or something like that, and you've got component parts in it that slide past each other, there are potential risks of trapping fingers or possibly even quite bad injuries because of those components. And you might talk about how you might mitigate those risks in real life. So think about how the product is used in real life. It's an opportunity to get marks in other sections as well. In terms of what you're doing, show that you're using strong health and safety working practices throughout. You've got a good idea of all the different components, parts, and how they need to be controlled. Here we've got a generic one. So we've got generic, low, medium, and high. There are not specific tasks. It's pretty kind of on the face safety. There's a place for this type of stuff within the work you do, but you need to also go into the depth as well. So if you only produce something like this, you're looking at very low marks. This is a better one. So it's a generic one again, but you'll see in a moment that this moves into much more succinct planning and risk assessment. Overall considerations of tasks and the health and safety issues associated with them and the risk. Importantly, what's here though is it means that the candidate has numbered them, so 1 to 6 in terms of the things she's going to be doing. That's really useful, but it also means that she doesn't have to repeat herself constantly in other sections where she just says the same words. So it's useful to have a generic system in place that you can refer to. She's also got some information about COSH and how she'd look at other aspects within the hazards. This is then her planning. Now, her planning is really good, and this is the sort of thing that I would expect to see from a high grade student. So we've got the component parts that you'll notice they're lettered up above. We then talk about what material they're being cut with and how they work. An image here might have helped us to understand what they look like, so it could have been slightly better. We've got tolerances that are being applied in checks. We've also got risk assessment being brought in here. One of the things I will say, the risk assessment refers to the numbers on the previous slide we've just seen. Great. However, it doesn't then go into real detail about the actual tasks being carried out. Because of that, it actually drops marks. So bear that in mind, that you probably want to make sure that you've got more focus on the actual tasks. In addition to that, we've also got pictures that are coming in. I've got no problem with pictures coming in. However, you need to make sure that the plan for production appears that it was written before you undertook the manufacture. And sometimes by dropping images in, it makes it look like you did it at the same time. So think about how you're using images, and there's no problems with putting those in to help demonstrate how your testing parts are in the right place, or how things need to marry up or meet up, or where quality checks are. But you probably want to do that in a way that shows that it was done after the planning. Finally, we've got this one, which is another generic method of doing it in looking at risk assessment. I don't think it's as good. However, it is looking mostly at, a wide breadth of tasks that could be undertaken. And what's nice about it is that we've also got control measures and then possible further control measures that are being added to show that the student understands how to make them as safe as possible. I'm not saying that you should all go down this route, but it's good to see that level of detail and that level of consideration because it feeds in well to the mark scheme. Okay, from here you should also be then looking at quality of the final prototypes and where you're going with those, and also the viability to see how viable those particular prototypes are. I hope that's been useful for you. Like and subscribe. Thanks for watching DTTV.